Hello, so I'm guessing you've made a lovely level in GameMaker Studio 2 using the new tile set system, and now you want to learn how to get an object to collide directly with that tile map rather than the usual method, which is to create a wall object of some kind and spray that all over your level. How do we use the tile layers to just create a nice collision mask that we can collide against? Doing this isn't a whole lot harder or really all that different to doing collision checks against wall objects, but it is a bit less flexible in the long run, but it does run way faster, and it makes level editing and room editing a lot more bearable. Has a number of advantages in that regard. So let's get in there. All I have at the moment is a basic environment, not even platformer physics, just a rectangle hitbox that I can move around, just so I can demonstrate the collision. It's not even, I think the center of it's over here somewhere, just so we can show that it works with any kind of arbitrary rectangle shape. And that's all we really need. We don't really need to, if you want to wrap this, it works exactly the same if you're going to do a top-down game or a platform game, whatever. It's just collisions, right? So this is all we really need. First of all, though, I'm going to make a layer dedicated specifically to collision. That's just going to keep things easier to control, and I just have a simple tile set for doing this. So if I come into my room here, I'm just going to add another tile layer. You see I've already just got kind of a basic thing with dirt tiles and trees and backgrounds, just to sort of have something that looks vaguely like a video game. I'm going to create a new tile layer. I'm going to F2 and call it collision. And I'm going to select a tile layer I've got that's literally only got, a tile set rather I've got that's only got one tile in it, just a sort of semi-transparent blue square. You can use whatever you like, really. If you want to make your collision stuff more advanced later on, you might have slope masks or something in here later. But this layer isn't actually going to be visible to the player, we're just going to use it to mask out the shape of the level, so I'm going to do that now. Okay, so that's everything we need. As I say, I can just click this little eyeball up here just to turn the visibility on and off for this tile layer. And while it's off, it's still going to work, okay? Our code is still going to find the tiles there, it's still going to work with the tile map data. It doesn't care whether or not it's actually visible. So we can use that just to be able to create the mask of our level in the level editor, and then it won't actually appear in the game, just the same as when we were using objects for collision with the other system. Okay, so let's come to our player object now. Let's hit up the workspace. I've already got them open over here. And just in the create event, the first thing I want to do is get the ID of the tile map that we just created, okay? Because I mean, this is a tile layer, and on that layer is a tile map, and we need to get the ID of that tile map for our player to be able to work with. We only need to get it once, unless we were updating the tile map and changing it mid-game or whatever, then we would need to update it every time we did that. But for now, we're just going to assume that our tile map is fixed throughout, and we're just going to get it once at the start. So I'm going to type tile map, just as a variable, equals layer underscore tile map underscore get underscore ID, and then open brackets, and I've named the layer collision, so I'm going to type in quotation marks collision, the full name of the layer. Okay, and that'll get the tile map ID from that layer, and now it's just stored in this variable, and we don't need to call this again. We just call it once when the player is when a player is created, and we're set to go. Okay, so that's all we need from the create event. I'm going to come to the step event now, and I'm going to maximize this and bring this away, because this is basically where we're going to be doing everything else. Okay. And we want to be able to see what we're doing. So as you can see, my movement code in here is incredibly basic. I just I get my inputs, we work out where we want to move, and we move there. And so if you've done collision stuff before, you'll know that once we know where we want to move, what we do is check to see if we can move there, and if we can, then do it. And if we can't, then reduce our speed to 0 and move as close as we can, okay? In this case, with our 32 by 32 grid, we're going to basically snap ourselves to the grid in the direction that we're moving when we find a collision. What we want to do is detect, basically when we're moving in any direction, we want to check 2 points, okay? We want to check the, and it depends in which direction we're moving. If we're moving to the right, we want to check the top right and bottom right of the collision hitbox, the bounding box of our object, okay? If we're moving down, we'll want to check the bottom left and the bottom right. If we're moving left, we'll want to check the top left and the bottom left, or if we're moving up, we'll want to check top left and top right, okay? Just those 2 points on each one. Okay, this does mean, by checking it this way, you kind of want to keep the collision box smaller, or either the same size or smaller than the size of your tiles, okay? Mine's like a 32 by 32, just arbitrary kind of square rectangle thing, but it's in a 32 by 32. To make sure it's this size or smaller, okay? The reason I say that is because otherwise you could end up with situations, you could avoid it with level design, but like you could end up with situations where you could, if the top and the bottom goes sort of over and under a collision, you could sort of move through a block and so on. If you want to make hitboxes that are bigger than your tile set, then you could do that. You just have to work in like an extra point check, so you'd have to check sort of the middle and as well as the tops and bottoms and so on, okay? So let's do this for horizontal first, just because it's on top here. First of all, we want to check to see which direction we're moving in, if we're moving left or right, because as I say, that affects which points we want to use. In fact, before I do this, right at the top here, I'm going to write var bbox side, okay? This is a variable that's just going to help us track which side of the bounding box we want to check. If we're moving left, then it's left, right, then it's right, up, then down, you know. So first of all, just our horizontal stuff then. If HSP greater than 0, okay? So if our horizontal speed is greater than 0, then we know we're moving to the right. Otherwise, we're either not moving at all or we're moving left. If we're not moving at all, then none of this will matter because there obviously is not going to be a horizontal collision. And if it's actually less than 0, then obviously it's negative when we're moving to the left. So if we're moving to the right, bbox side is going to equal bbox right. You see that one turns green, that's a built-in thing. Bounding box right gives you the X position of the very right edge of your bounding box, okay? Really, really useful, and that's no matter where you are in the room, it'll return the X coordinate of the right edge of your bounding box. And there's a similar one for left, top and bottom, which we'll be using throughout this. Okay, so I'm going to semicolon there, which ends that if statement, but then write else on the end of it. So if that's not true, then we do what's after it, which is bbox side equals bbox underscore left, okay? So either we're moving right, in case we want this to be our right side, otherwise we want it to be the left side, okay? Simple stuff. Next up, I'm going to check the actual tile map, okay? So I'm going to type if, open bracket, tilemap, get at pixel. If some of you more advanced among you, the moment you see that this command exists, you probably already know what to do for the whole rest of this. So go ahead. If the rest of you stick around, tilemap get at pixel tilemap, comma, bbox underscore side plus HSP. Okay, similar to what we do with our regular collisions when we just check a position, okay, but we're checking a specific pixel here. And the Y coordinate is bbox top. Okay, and we'll say that's not, if that's not equal to 0. So let me explain this line a bit better. So tilemap get at pixel, basically we take a random pixel, well not a random pixel, we take a given pixel, that's this coordinate, in our room, and we compare it to the tile map and we work out what cell of the tile grid that is. It just does some very simple maths to work that out. It's really quite a quick check. Simple maths works out whereabouts in the grid that pixel lies and what tile from your tile set is in it, okay? It actually returns a bit of data, so it returns like whether or not, it turns the index of the tile, so it tells you what tile is that, but if the tile is flipped or rotated as well, which is something you can do with tile sets and so on, it'll return that data, which will make this more complicated than just an integer. But since this is just our collision layer, I'm going to assume that you're just going to use just one tile, you're not going to be flipping and rotating it or doing anything particularly weird with it, okay? So it's fair enough just to check if it does not equal 0, because if it's not 0, then we know that there's something in that tile, okay? Simple as that. And if there is something in that tile on tilemap, which is our collision layer, then we know it's one of these blue blocks, and we know that that's somewhere where we're going to collide, okay? And the position for that is, I say the very top of our bounding box for the Y coordinate, and whatever side we're using, so either bbox right or bbox left, plus our horizontal speed, so that's the position. Basically the top right of the box if we're moving to the right, okay? And the top left of the bounding box if we're moving to the left, okay? But we also need to check the bottom. So let's type in OR command in here. That's 2 vertical lines like that. Or the OR command, I'm pretty sure works just the same. Open bracket, tilemap, get at pixel, so same command again. Tilemap, bbox side plus HSP bbox bottom this time, okay? Does not equal 0 again. Close that as well so we can see the whole line of code. Let's check I've got my brackets correct there. Yeah, okay, so it's the same line twice. One is just checking the top right and one is just checking the bottom right, or if I'm moving left, bbox side is left, so the top left or the bottom left, okay? So if one of those is 1, then we know we've got a collision. Either the top right of the box or the bottom right of the box has hit a wall, so we know if either of those are true, then we're colliding, okay? Both of them can be true, or either one of them can be true. And if neither of them are true, then we're not, and we can go ahead and just do x plus equals HSP. So normally in here what we do is like with a regular collision, we do like a while loop, right? And we move like the object closer and closer. We're not going to do that. We're going to be a bit more clever about it, and we're just going to quickly, in one step, snap ourselves to the 32 by 32 grid, because we know that our tiles are always going to be 32 by 32 blocks in a 32 by 32 grid. So all we need to do is snap the edge of our bounding box just against the grid, okay? So how on earth do we do that? Well, basically we're just going to do a little bit of clever maths. I'm going to type if HSP greater than 0 again. You'll spot throughout this, by the way, that there are little optimizations I could do, like I could calculate this just once and put it in a variable. But I do things like this but for two reasons: to keep the logic laid as bare as possible, to make it easy to understand, and also to cut down on extra lines of code we're writing for efficiency reasons, and just to make the video shorter, cleaner, and easier to understand. So sometimes you might see me write things that are not necessarily the best way to write things, but it has been thought about, okay? It has been thought about and it's been done in a specific way to help you learn the best things possible. So if HSP is greater than 0 again, so if we're moving to the right again, x equals x minus, open bracket, x mod 32, okay? So this is new. This is a fun little maths function. You can also do it by using the percent symbol, which is basically, it's meant to look like the divide symbol because it's very similar to divide. What mod does is it divides the first number by the second number, but instead of returning the answer of the division, so x divided by 32, it returns the remainder of that division, okay? So just for some examples, 30 mod 32, 32 goes into 30 0 whole times, okay, it's 2 off going into it 1 whole time, so we're 30 left over, okay. 42 mod 32, with 32 goes into 42 once with an extra 10 left over, okay, because it's 10 more than 32. 64 mod 32, or even 32 mod 32, would both equal 0, because 32 goes into 32 once with none left over, 32 goes into 64 twice with 0 left over, okay, they cleanly go into it. 66, however, mod 32, would go into it twice with 2 left over, because it's 2 more than 64, okay? So hopefully that gives you an idea of how mod works, okay? It's division, integer division, so like the whole number of times it goes in, and then it just produces the remainder of that division, okay? And the reason that's useful to us is because by taking our current x coordinate and removing x mod 32 from it, it snaps us to a 32 by 32 grid left of wherever we are. So if our x position is currently, say, let's say it's 38, okay? We take 38 minus 38 mod 32. Okay, and that will give us 38 minus 32 goes into it once with 6 left over, 6, which gives us 32, right? So that snaps us to the 32 by 32 grid. That's what that does, always to the left side of it. But we're moving to the right, so we actually want to snap to the right hand side of this. So how do I do that? Well, pretty easily actually. I just add 31. Okay, so if we're at 0, if we end up snapping to 0, we go to 31. If we're at 32, we end up going to 63, and so on. So why am I adding 31? Well, because that's the actual width of the tile set, the tile grid rather. From the top left of the tile grid is pixel 0, and the far right of that first cell is pixel 31. That's the far right edge. If it were to be 32, that would actually put us 1 pixel into the next cell, okay? And that would put us on the far left of the next cell, which is not what we want. We want the far right of the cell we're currently in, so it's 31, just 1 pixel less, okay? Hope that makes sense. And then that's basically it in terms of putting our x-coordinate in the right place, but our x-coordinate is where our origin is, and I think if I look at the player sprite, like it's in the middle here, so it's going to put that point on the edge, which is actually just not going to be quite right. What we want is to line if we're going right, we want to line up the right edge, this edge here, with the edge of the tile, not this point. So let's come back into here now. All we need to do is adjust this position now by whatever the difference is between our origin, so our x-coordinate, and the bounding box on the right, okay? So we can simply do minus bbox right minus x. Okay, so that's the very right edge, minus x, which will give us the difference between the two, and then we just subtract that just to move us a bit further left, just by the right amount, by however wide our rectangle happens to be. I'm going to do a few of these in brackets, and technically, let's say there's another sort of optimization thing. You wouldn't want to do them every single frame, because this is going to be the same. No matter where we are in the room, this value will always return the same amount. It's because it's literally just going to be the difference between this position and this position, like in whole pixels, no matter where we are in the room. So if you want to optimize further, you could put this into a variable in the create event, but as I say, I'm going to skip that for reasons of keeping it clear what we're doing. So next line, this handles when we're moving to the right, okay, exactly what we want to do, and when we're moving to the left, we almost want to do exactly the same thing, but it's just a little bit different. So I'm going to write else underneath here, so if that statement's true, then do that, but if it's not, then we do this, which is x equals x minus x mod 32, so same thing again, but this time we actually want the left edge, so we're not going to add 31. We don't need to add the 31 on because we've got the left edge that we were after. Instead, all we need to do is do the same thing again, but where we're subtracting this difference, but instead of getting the right hand side, we get the left hand side, okay, because it might be different, and you can see it is, like the pixel here is a slit, the origin is slightly more leaning towards the left on here, and we want it to be able to work no matter what shape our box is, or no matter what sort of size our box is, rather, dimensions of it, whatever is the most accurate thing you could think to say there. So bbox underscore left minus x. Okay, this is the exact same thing, it's just the different side of it, okay? And that snaps us to the grid. That's all we actually need to do that. Other than just set our speed to 0, okay? And that's the last thing we did the last time we did a collision thing. That should be everything then. I'm just gonna comment that with horizontal collision and quickly run this just to check that this is all working and I've not forgotten anything done. You can see, I mean, I've left the tile on display here, but that's perfectly good just for highlighting that it's working properly, and if I move vertically it's not going to work and it'll do some weird stuff because the horizontal collision will be working but the vertical isn't doing anything yet. Okay, so that's all working as expected. Oh, did I leave a gap in there? Looks like I left a little gap in there. Collision, oh yeah, okay, let's fill that in so it looks proper. Good, and while we're here I'm going to make this invisible, and then that'll demonstrate that it works regardless of whether it's visible. So for vertical collision, you might have well guessed we're just literally going to do the same thing. So I'm going to copy that whole chunk of code except for the bottom line, obviously. Change this to vertical collision. Change every instance of HSP to a VSP. There, that's already done at the bottom. And there's one thing here you may have already noticed, which we'll come back to, but just change all the HSPs to VSPs for obvious reasons. Change all the Ys, the X's to Ys. Like so, because it's all the same values otherwise. But in here, where we're checking the tile map in the first place, we want to check the Actually, before that, we'll do it from the top. It probably makes more sense. So bbox side in this case isn't going to be right or left. It's going to be top or bottom. So if our VSB is greater than 0, we're moving down. So bbox side wants to be bbox bottom, or bbox side wants to be bbox top. Okay. And then we want either the bottom left and bottom right, or we want the top left and top right. So let's swap this around. Put it there. And fill this with, so we'll check the left side, bbox left. So either the top left or the bottom left here, plus our current vertical speed. And do the same thing on this side. Let's pick this up actually. Should have done that before. Cut that. Paste that there. bbox right. Okay, so either the top left or the top right, or the bottom left or the bottom right. Okay. So it's otherwise just the same thing. Okay, so then once we've done that, let's come down to here. We need to change this, because if we're moving to the right, we want to check the difference between. If we're moving down, sorry, if VSB is greater than 0, we want to check the difference between the bottom edge and the Y coordinates. Let's change bbox right to bbox bottom. And here, change bbox left to bbox top, okay? Because top is the negative direction, and left is the negative direction, and right is the positive direction, and bottom is the positive direction, okay? And that's everything. That should cover everything. That should be pixel perfect, clean, collision, handles corners, handles everything. So yeah, just neatly pixel perfect, just snaps you to the grid if you would collide. Okay, which is a lot cleaner, a lot more efficient than doing sort of a while loop with object collisions and moving like 1 pixel at a time on a single step until you get like right to the edge, and all the logic we used to use before. And it's just it's a far more efficient check in general, checking just the tile map, just checking a grid and just using simple maths. Like the whole thing is just very simply maths based. It doesn't really have to get much data from like any specific pixels or anything like that, really. So GameMaker just crashed, but the last thing I was going to show you is that this really does work with any kind of shape of player, sprite, or whatever. Well, any kind of rectangle that you can imagine. So let's make it a bit like uneven sided as well. And just so it's a bit of a different shape to what I've been working with so far. You will want to make sure though that your origin is still sort of inside the bounding box. It doesn't have to be perfectly centered or anything like that, but just make sure it's in it. If it's outside it, that can create some issues with how we worked out sort of the difference between positions and so on. But as long as the origin is inside your bounding box, it should work just fine. And obviously our bounding box is automatically calculated from the shape, and that's why I'm just using a square. It's not a precision mask or anything. So if I run that should just work in the exact same way. Yeah, all collides perfectly, pixel perfect and flush against the mask that we created, nice and clean. So yeah, that's how you do it. That's how you create collisions between a player object and a tile-based collision mask. Thank you very much for watching. I'll catch you guys next week on Platformer Part 6, I think, something like that. Platformer, yeah, I think it's Part 6. Either way, I'll see you guys then. Thanks for watching. Catch you guys next time. A big thank you as ever to my Patreon supporters who selected the topic for this week's video. A special shout out in particular to Inner Mule, Alex Ray, Giles Montgomery, Dan, Angel Rodriguez, Harold Gidry, Rockzom, Stephen Hagen, Jason McMillan, and Owen Morgan. I hope I've been saying all your names right this whole time. I apologise if I haven't. I'll see you guys next week.